morning. I'm Rex Bombardelli, design director at 2Portzamparc, and today I would like to tell you a story of the biggest building, the largest building that my office have ever built, and one of the biggest building ever in the world. It's the China National Convention Center. It's located in Beijing, 10 kilometers north to the Forbidden City. It is located in the Olympic Green, which is the Olympic Park for Summer Olympic Games in Beijing in 2008. And you can recognize some iconic buildings such as the Bird Nest and the Water Cube. And at the beginning, the first contact we had with the client just sent this plan here and the location of the project. And he said, the building will be on the block B25 and B27, B26. You have a nice park in front, and that's all. And if you look at the size of this grid, nothing is weird. The proportion between blocks and street looks normal, usual. And so the first surprise we had is when we tried to measure it. And so we discover that the two blocks were 500 meters long and 200 meters wide. So we're like, wow, okay, never seen that. And so, because we are optimistic, we say, okay, we have a lot of space, a lot of rooms to put our building in, and could be a good challenge. And then we have a call with the client who said, the building has to be aligned to the boundary line, to the property line, so no setback possible, no recess, nothing. So we realized that the building would be that big. So one single box that bridge the two blocks. And so we are like we didn't believe it. And, oh, sorry about that, I forget. Okay, this is the footprint of the building compared to the Manhattan grid. Yeah, and now we can say, okay. So the special approach, the particular approach I would like to have to you today regarding this building is its size. In fact, we struggled to understand how big this building would be, and when we discovered it, we didn't believe it. It's blocked. Oh, okay. So we try to figure it out how big it was. We try to at this point, to make some comparison with other buildings. Now, the bigger building that come in mind are airport terminal. And these two pictures are in scale. So we compare our mega box with the Roissy Charles de Gaulle Terminal 2, and we see that we are almost the same size. Now, the airport for us is not a familiar building. I mean, is in the middle of nowhere. Is not usually is not in a city center, and in any case, there is no other buildings like residential buildings side to side. So it was not a good example. So we need to find something more central inserted in a urban grid, and so we found the Louvre, the Museum Louvre. And now we realize how big our building would be, because the Louvre is quite well inserted in a urban grid. It's a familiar building. We can pass pass through almost every day. And so we understand that our way to approach the design process, we had to change it. We have to start to think bigger, larger, like we were the king's architect or the royal family architect. And even when we compared to the king's building in Buckingham Palace, we discovered that it's too small, so it doesn't help us. Okay, so we were completely lost at this moment. How we can think outside the box if the box is that big? It's impossible. So we received from the client the first very detailed list of the function. That one. Yeah, and we tried to discover what that means. And we discovered that the 8,000 here in reality is not the area, but is the seat of the conference room. And then they said a very detailed section, okay? And one of the guy of my team, for a joke, say how the number of the side should be the height of the floor. Haha, and he was right. So now we knew that the building would be 45 meters high with only 3 stories. So yeah, completely crazy. So we were quite lost, and in this case, we start to try to break the huge mass in a smaller elements, especially to avoid an urban disaster, right? Because otherwise it is a barrier of 500 meters long, and it's not human-friendly at all. So we try to imagine some passages inside, some cover garden, some roofed square, to make it more familiar with the visitor. And then a few days later, the client, we received the real function list, which is this one. Okay, so we passed from this scheme to that one, and we realized that it was so dense, so with a lot of area inside that nothing was possible. So there was no empty space allowed, no setback, nothing. Just a big box. And we see here the sadness of the designer teams, and the more and more sad the project, until we was desperate, and we begged the client to remove some function, the area, to make it smaller, to allow it to sculpt a little bit this volume, and to allow the shadow to make it more friendly and to welcome the visitor instead of having a blind wall, a big wall, and is accept, hopefully. And so we came out with 2 options, and we were quite happy about that. And then the client said, yeah, it's nice, but we need something more solemn, but not monumental. So solemn applied to a building means nothing and means everything at the same time. And so we asked to the client, can you please show us a building that you consider solemn? And so he sent us that one here. And so we answer with this project here. We add columns. So the client was happy, the concept design, the end of the concept design, but the fight was not finished because we had to deal still with the monumental size of this building. Now, if you look at the results, this is the three of them, the comparison. If you look at the results, the building doesn't look that big in reality. And this is because of different factors. Some factors was already in place, means that the position of the building in the urban grid doesn't allow a frontal approach, so only on the side, so systematically on one of the corner, so the building appear all the time in perspective. So this is an advantage. And then the second one is there are no other buildings close enough to scale our building. Now, if you look at this other facade here, which is the Opera House in Shanghai, is easier to scale because we recognize some elements. But first of all, we have a building on the left, then we have cars on the bottom left corner, we have trees, and if you look more closely, we can see doors and parapet. So it's easy. So you are not surprised at all when I show you this picture compared with the human scale. There's not any surprise. But if I show you this one, you have no way to scale the building, nothing. So you need a tool that allowed you to give a scale of this building. And I give you a tool. This is the tool. This is the size of the panel compared to the human scale. Now you can scale the building, and I will help you. I put the little guy here for the guy. So it could be possible. It's usual. But what if I tell you that this guy here, in reality, is not a guy, but is a little guy, like this? So now the perception of the building changed radically. So I have the keys to make you understand whatever I want. It depends on the tools that I give it to you. And in reality, this is the real size of the panels. And now you can realize this is here, little panel. There. The real size of the monster, of the beast. So we have still the little guy on the roof, so he's almost invisible. And okay, so we was not enough to have this natural location that allowed perspective views. We need some other tricks. And one of the tricks is the size of the panel. So the bigger the panel was, the smaller the building appear. And the second one was to try to make completely transparent the junction with the ground, which means that visitor, when he approached the building, he can see the life inside. It's a welcoming, and it's different that crashed with against a blind wall. And to make this possible, we remember that there are only 3 floors. So the ground floor, the first floor, and the ground floor is 18 meters high, and the second floor. And to do this, to realize this vision here, we needed some high engineering skills. Yeah, it's a little video just to tell you a story. That the facade, the middle facade here with the tiny little windows, we called the bird's facade because of the bird nest next door. And so it's supposed to be the birds taking off to fly to the birds. This is this kind of story, Chinese love this kind of story. So this is why we called it the bird facade. And to realize this bird facade and the upper facade, it was very challenging because, in fact, the upper facade is hanged on a big truss hide on the roof, and the bird facade is hanged to the first floor slab. So nothing on the ground. Everything is hanged. And to avoid this kind of distortion here, because the facade is like only one point, the diagrid, so the grid here, was specially designed both to resist this effort and avoid any obstruction to the light, to the bird. And then in the diagrid, yeah, then it's simple. There's isolation panels pre-assembled in a shop, and then fit a stick on the grid, and then at last the panels. And here you can see the construction process, and here as well. And because we would like in interior to have a light effect, like this one here. Okay, so we design the openings in section to allow the maximum amount of natural light, because this facade is facing east. So there is only few hours a day of direct light, like 3 hours. And to maximize this light, we special design the section to allow the light to enter. This is why in the interior part, the windows are flared like this. And so if you come back to the panel, so we say that the bigger the panel was, the smaller the building appeared. It was a really challenge, because first we start to study which material. So we try with ceramic, we try with all types of concrete, and in the end, because of the huge size and to have a reasonable weight, we choose metal. And we had like few panels, in reality, only 4 panels, 5 panels. And to have this bump here, this relief, only one process was possible, was to press the metal sheet in a press machine with mold. And because the pressing machine for pressing steel was bigger than the pressing machine for aluminum, so we will choose steel. And we have here a little animation about the process. So yeah, the panel is first laser cut to make the openings. Yeah, and then second machine is to press with mold and give the bump. Okay, and then there is other 7 processes to bend the panel, to make some other fine adjustment. And here we can see a picture of the press machine here, the 2 mold, because we have a negative and a positive to press. This is the panel freshly came out from the chain. Then this is all the process. And the interesting part here is the last three ones, the 7, the 8, and the 9, because after all the pressing process, that we need to bend the panel, to curve the panel with a secondary structure, because don't forget that the facade is curved. Each panel is curved slightly. But the result was quite nice, was quite thin, though we was happy about that. And yeah, and cherry on the top, because the facade was so long, so we have more than 1 kilometer of facade, because we have 4 sides, so 1 kilometer. For the cleaner guy, was a nightmare. So it was so long, takes so long to clean all the facade that we invented a special, not invented, but we tried to figure it out how we can reduce the intervention of the cleaner facade. And so we decided to coat the steel with enameled, 2 layers. It is both to preserve the whiteness of the building, and second, to protect the facade from the dirty rain of Beijing. Often they have a desert storm, sandstorm, sorry, from the sand come from the desert on the west. And now, yeah, I didn't want to finish my presentation in a bathtub, but it was interesting to know that the same process of our panels is used for bathtub. In fact, it is molded steel coated with enamel. Well, thank you.